Hi all. This unit 2 lecture series. The next one is dual rail logic and NP CMOS logic and or array logic. So these things we are going to see in this video. And what is a dual rail domino? We know that domino logic, right? So we can get the non-inverting output from the domino logic, and whereas in dynamic logic we can get the what we can get the inverting output like a dot b whole bar, whereas in domino we can get a dot b. So that is we have seen, right? In this dual rail domino we can get both true and complementary output. Okay, so we are getting input the same like true input and complementary input, as well as we are getting output true output and complementary output. That is the beauty of dual rail domino. So we don't want to go for separate circuit for getting inverting and non-inverting output. Single circuit we can get both inverting and non-inverting dynamic domino logic outputs. Okay, right. Here we can the gates encode each signal with a pair of wires. Okay, the input and output signal pairs are denoted as s underscore h and underscore low, right? Underscore h means high input and low means low input. Okay, that what is the meaning also have tabulated in this slide. When both high and low are 0 0, which means it's a precharge state, right? When it is 0 and 1, then it gives the 0 output, it is logic low, and 1 0 it's 1 output, whereas 1 1 it's an invalid signal. Okay, so this is a concept behind the dual rail domino. You can see the concept by circuit diagram. See, in this is same structure as we looked previously in a differential cascade voltage switch logic, whereas both the pull up network PMOS transistor are cross coupled, but here both are tied together and triggered by clock, right? Triggered by clock over here. And like a dynamic, this is a dynamic domino dual rail domino logic, or we can say that a dynamic CVSI. Okay, uh, here so we're having two signals, two output signals, which is fed by inverter circuit, that is y underscore h and y underscore l. Here we can get a dot b bar whole bar and a dot b. So NAND and AND gate logic we have derived here, and we are giving input both a underscore h b underscore h in left side of the network, right? And a underscore l and b underscore l, so which we are giving in the left side, and a underscore h b underscore h are right side. Okay, which means we are taking both high input and low input, and we are getting the output like a dot b and a dot b whole bar. Okay, there is one advantage over here to get both complementary as well as true values. We can get it over single circuit, but the main drawback is that it's making number of wires it increases. Okay, so even though we are getting two logic signals in a single circuit, but so number of transistors as well as getting wiring connection becomes the major issue, and power also it consumes more in this dual rail domino logic. Okay, so I can conclude with this, what is dual rail domino. So we don't have a both non-inverting and inverting output in the domino logic. So to attain these by using this both to get both inverting and non-inverting output in a single circuit, we are going for dual rail domino. So here we are giving both inputs, true and complementary inputs, and we are computing both true and complementary outputs. So this circuit, which represents a simple and NAND gate, dual rail and NAND gate. So we can design the combination of OR and NOR gate logic also, dual rail, R and NAND. So the circuit for NMOS and NMOS transistor pull down network only will vary. The remaining all are same. Both PMOS transistor are tied together and triggered by clock, and footed dynamic logic footed clock transistor also attached at the bottom of the circuit. Then you are getting both the high value as well as complementary, true value and complementary value, A at B and A at B whole bar. Whereas in an R and an R, we will get A plus B and A plus B whole bar. Likewise, we can go for XR and XNOR gate also. Okay, so that is the real rail domino logic. What is NP domino logic? So the same structure which is cascading with N logic, P logic, N logic and P logic. Okay, so for single circuit we are using one domino logic. That domino logic is cascaded with series of N and P, NP, NP. So that is NP domino logic or NOR A domino logic. So here when pi equal to 0, so first stage and third stage are getting activated, right? When pi equal to 0, the second stage it's turned off. So both the N stage get activated, whereas P stage is getting off, right? So once it's calculated, that is signal is forwarded to the next P logic. When pi equal to 1, so N stage are getting turned off and P logic is getting turned on. Okay, so this nature gives the NP domino logic. So I'm taking simple example for second stage. Okay, when pi equal to 0, the first and third stage precharge happens. The second stage pre-discharge has happened now. Okay, pi equal to 1. So when pi equal to 1, all the stages comes under the evaluation mode. So in this one and third stage comes under the evaluation mode, right? So this design style is called NP domino logic. Okay, whereas the NOR A CMOS logic, which gives the same what we have seen in the domino logics, just an inverter is connected. Okay, so what the output, so for going for pull down network and pull up network, so an inverter is connected to deliver the output. Okay, this will ensure this will ensure the NOR A CMOS logic style. So I hope understand about what is dual rail domino logic, NP domino logic and NOR A array logic. Thank you.